have sequence numbers. So in other words, if I have a data going in and one of them got lost, there's an alert because this will become out of sequence. We need to have a rejection, and then to acknowledge the actual sending of the data. Meanwhile, if an actual RR, a receiver ready or an acknowledgement got lost, we don't care if another one came afterwards, acknowledging whatever they received, because they are not the ones that need to keep the order of the messages. The iframes are the most important part. These are the one who creates that reliability, provide those order of the messages. So keep that in mind. The iMessages are the data messages which provide the reliability criteria within the messages. Okay. Question number 3. Explain the role of an I, RR, or a reject. What are these? We already said that I is your information frame, your data. This is I, your information. So that's the role of it. Keeping control of those information will provide your reliability. This controls your siding with the protocol. What about RR? Or we call them acknowledgements. An RR means your receiver is ready to receive any information, any notes, whatever that is. So a receiver ready indicates to the sender that I'm happy to receive any frames. That's an acknowledgement or a receiver ready. Okay? This is what we call a supervisory frame. What about your reject? What's that? A reject is whenever there is a frame, or an iframe out of order, not in the right sequence, you need to reject that and request from the sender to send you all the information again. The ones got lost. What's R&R? We haven't used that, and we will never use that in sliding window protocol, but you need to know that. That means the receiver is not ready to receive. Either he's busy, and there's an issue with the actual connection. So R&R means the receiver is not ready to receive. Again, that's not going to be used in your sliding window protocol. These 3 will be used heavily in our applications. What stateful information is carried in the control field of each of these frames? Sorry? No. Data are actually the frame I, so they have a control frame. And control frame usually will have information of address, information of sequence numbers, other details. So in reality, you don't need to worry about them in sliding window protocol, but they have the whole information required to be delivered to the right addresses. Explain the concept of flow control and how it's implemented using these frame types. And if I would say, what kind of technique, let's put it that way, what kind of technique in sliding window protocol creates your flow control, or controls the flow control within sliding window protocol? First of all, what's flow control? You need to pace the actual incoming link to the outgoing link. I.e., you don't need frames lost because of the incoming being higher speed than the outgoing. What kind of technique we've used, I explained in the actual sliding window protocol that provide that. What did they define?
Point-to-point protocol.
You know, with the sliding window itself. I've defined 2 main things. One of them can create that flow control.
The window size.
Window size, perfect, thank you. Window size is in reality flow control. Because if I would say you're allowed to send 4 messages and only 4 messages, if you try to send a 5th one, you're not allowed unless you receive an acknowledgement. Therefore, you're pacing the actual connection between the incoming and the outgoing. All right? Any questions? This has nothing to do with the actual sliding window, but we need to understand the concept behind whatever being defined as a reliable service and how we do this. Good. Now we're going to look at examples, which will be very effective with sliding with the protocol itself. I'll give an example that I'm going to provide in the exam. We'll give you different examples, and we'll see why are they important, why are they not important, what happens, what's kind of situation you need to understand, what kind of correction you need to do, and so on. Let's read the concept. We're saying that fragments of fault timing diagrams are shown below. A standard layer 2 reliable protocol is in operation. Note that for simplicity, we are using a half duplex only, i.e. one direction only can send, hence there is no piggyback acknowledgement. Assuming that no other frames are due to be sent in either direction, then for each diagram, 1, describe a situation which exists, 2nd, explain what happens next and why. Solve the first one. What's the situation and what's going to happen and why? That's something. Whenever you're ready.
The second packet has been lost.
So first of all, first packet is sent, arriving successfully. Second packet arrived, did not arrive, lost for any reason. Third one arrived. What is the situation?
Only the first packet is received.
Okay, so what would the receiver do?
It will stop, but the other ones will just let you know that the second packet wasn't received.
So what will he do?
It won't accept it.
Good, so the first one arrived, it's fine. Second one did not arrive for any reason, an issue. Third one arriving, so what's that? That's out.
It's dropped. It's dropped.
That would be true because it's out
as
of
we've
order.
seen, yes,
Because we had 0, 1, and the second one. Because this is not, eventually, you remember what I said, you need to compare the variable of the sender with the variable of the receiver. And if they are equal, you increment. If not, there's an issue. In this case, it will not be equal. The other side will reject, sending a rejection and acknowledging whatever has been received. In this case, we'll be receiving 1, saying that I've received only 1 frame. Exactly. Yep.
Oh, you lost me on that whole thing that you said.
Whole thing, that's too much. And main thing in reliable assigning with the protocol, you need frames to be in order. Alright. First one sent, arrived perfectly. Second one sent, did not arrive. So by now, the third one, if it arrives, how do we check? We usually, if I complete, let's look at the slide here. Consider this your variable of the sender, the variable of the receiver. First one arriving, is 0 equal to 0? Those two, variable sender, variable receiver, they are equal. So I can increment my variable of the receiver. And I increment my variable of sender. That's fine. Second one, did not arrive. This guy will not receive anything. He will not update his information. Meanwhile, the sender will update because he thought that this arrived to the destination normally. So he'll say, that's 2. Meanwhile, here, this is still 1. Haven't changed anything. Did not arrive. He sent the third one. Third one arriving. So what do? As you're actually controlling things, you say, is the variable of the sender, which in this case was 2, equal to the variable of receiver, in this case is 1. You say no. You know it's out of order. Therefore, you need to reject and say that, look, I've received only 1 and everything before that. Therefore, you're indicating 2 and 3 are missing. So you retranslate it. This will be much clearer whenever we try to do the actual questions.
It makes sense now, yeah.
Main thing you need to know that sliding in the protocol will run perfectly. If I give you an exam question, an example, you need to make sure that everything is running. You shouldn't time out. You shouldn't go over your window size. So you need to make sure that everything works perfectly. How is that being done? We will hopefully try to see it. Okay, that's the first example. Let's go to the second one. What's the situation? What's happening is describe.
First 2 packets are received.
Okay.
And the acknowledgement, the receiver ready, it doesn't arrive.
Okay.
But it sends a packet anyway.
He doesn't know.
No, so it sends,
So everything is continuing as it is. You see,
oh, yeah,
the
it still continues, but
so
the window size must be.
What's the issue?
There isn't really one except it hasn't received an acknowledgement.
No, I haven't defined the timing here, but you will end up with an issue now, which is very similar to what we described in one of the examples within the lecture. Just look at the first one and the last one. That will give you an indication. What will happen if I leave it as it is?
It will keep sending the same.
So what will be the issue? What's the things that we need to make sure of not happening?
There may have been expecting an acknowledgement, and because it didn't get when it started it's reset and starts sending
So in
the
either,
same packets again.
so in this situation, it's either that packet is new and you're sending a new information frame, or either you're duplicating the first one and sending it back. So your sender doesn't know exactly what's happened. Did he receive it, either receiver or not? So you need to receive that acknowledgement. Whether that's in time or not, that depends on the question. But you need to receive that receiver ready or acknowledgement to indicate to the sender that those information has arrived successfully. Because now the sender will never know whether he's sending a new information, whether he needs a retransmission. If that's the case, that receiver ready needs to arrive. Of course, that will be bounded by the timer and eventually the question. But in here, as an open question, you need to receive that to know whether you send a new information or you are just sending a duplicate of it. That will be the confusion.
That doesn't mean that receiver should send acknowledgement every time.
No.
The receiver.
Receiver should send an acknowledgement based on your timer. So
But
unless
here
an
there is
information
not-
is sent with an iMessage, like a piggyback one I explained in the full duplex,
Yeah.
before time's out, you need to receive that acknowledgement. So let's say your timer is 3 seconds. So you count star 1, 2. Before the third millisecond, you need to receive that acknowledgement. Even if not being mentioned in the question, you need to receive that. Because as we said, our system is running an write operation without any issues sliding in the protocol. You shouldn't have an issue of a timeout or window size being full before you send. Third example was describe what will be the issue, if there is any issue. Very similar to the first one. Sorry, to the second one. But what's the difference here?
It sent it again anyway. Has it got two times?
Okay, 2 messages sent. The reply did not arrive. Lost. He sent the third one. He sent another reply.
Because it received the next packet in the sequence, it's just sent a request for an R packet again anyway. So even though it did mess up,
Okay.
the transmitter still knows that all the packets have
So
arrived.
is there an issue or not?
No.
No issues. So because RR are not important, not important, but there is no iMessage or actual data in it. So even if one got lost, but the other one did the job, that's fine. So in here you are indicating I've received 3 and everything before that. Here it's just saying I've received 2 and everything before that got lost. You don't care because this one is achieving the goal. So in other words, this is arriving in time. So there's no issues. Was that clear? Again, RR frames, if they got lost, that's fine. The main reason of RR is to acknowledge. If they acknowledge in time, fair enough. Another one have done the job for them, i.e. another frame, fair enough. If not, then it will time out. You need to receive that frame. Sure, we have another example. Yes, final one. Is there what's described and what's the issue and why?
It's not received the first one, but doesn't know that the other one hasn't got it, and it's trying to tell
Why
it.
doesn't know he hasn't got it? Because his
Because it's-
rejection did not arrive as well. So you send one, got lost, you continue sending everything as normal. Doesn't know. I.e. the sender doesn't know what's happening. The receiver did not acknowledge that one because he said this is not not the right order. He's rejected it, but got lost. You continue sending, he's continuing ignoring. What will happen eventually? Time's out. So here the timer will play an important role by controlling everything eventually. So timer is needed. That's a straightforward explaining everything in general.
How would the timeout know?
We will define time like 4 milliseconds. By the 4 milliseconds, if you don't receive everything, it times out and everything will be retransmitted again. Again, in our questions, we will never have that situation. You need to, there's, unless I tell you there's an issue with messages not arriving, that should never happen. So what I'll say messages is sent. For A is sending to B in time 0 and 1. Just make it very simple. B is sending, if it's a full duplex, to A in time 2 and 3. If you look at it, those messages are arriving normally. You will never assume there is an error. When there is an error, I will say, note, an error occurred in millisecond 3. So what I'm indicating the message is going from B to A, and the millisecond 3 did not arrive because of error. That's the only case where you have an error. And there you need to make sure that will never happen. By never happen, what will you do afterwards? Leave that whenever it arrives, so don't worry. We'll do an actual question. I'll leave that in the lecture because I don't think we'll manage to do it today. Okay, what I'm doing now, we've done the half duplex last time in the lecture, and I've hopefully asked you to do the full duplex. If you manage to do it, just show it to me. If not, I'll give you now 10 minutes to practice it. The practice is the goal here. Practice for 10 minutes, and I'll do it afterwards. Okay?
Question 4 or 5?
It's question 4 and 5 are related because question 4 is identical to 5,
Okay.
just the messages are different.
Fair.
So what I will say, I'll just give you the details here to make life easier. I'll say that this is a full duplex operation. In the messages below, these are the messages sent. You need to know that the window size is 3. So I define my window size as 3 messages. I cannot go over 3 messages unless they are acknowledged. And my timer is 4 milliseconds. Work it out. It's a full duplex. Look at the messages.
Are we doing fifth one?
Yeah.
So we're doing question 5?
Yeah, it's
Yeah.
5, doing 5, but the information of 4.
Okay.
That makes sense. Yes,
Because
so
we
question
did
5, please. I'll just show you. Usually a message, so I'm giving you the messages. How long does the message require to arrive from A to B? I'll say in the question, they are 1 millisecond. So a message sent from A to B or B to A requires 1 millisecond to arrive to the destination. Usually I'll say 1, maybe, but you need to know that information. So full duplex, so we have a variable number. If you have any questions, just ask me. Don't worry. For simplicity, try to use 2 colors for messages for A to B and B to A. So therefore you can track what's happening and you control everything. It'll be easier to track them. The best way of doing it, don't put all the messages, don't draw all the messages. Start with them by time. So a message A is sent to B as 0, at 1, then you go to 3, 4, back to 5, 6. Follow the time. That's the best way of doing it. Because if you draw all the messages, you might end up something being out of order, window size being full, you're not tracking it. So just follow it step by step. That's the best way of doing it. Don't forget, it's a full duplex. Messages going from both sides. Full duplex can acknowledge with the iframes, not just an acknowledgement. So you can't put an acknowledgement within an actual iframe. Yes. Messages are identical for both sides, i.e. a zero. If I send this, you will be challenged, so you'll be marked on the information in the message. You'll be marked on your variables, and there are acknowledgement, acknowledgement timers, and so on. You'll be marked on that. So 25 points are, you don't want to lose that by not trying to say you just follow the send. So when I say send, it sends at 0, arrives at 1. Whatever that is, that's the only thing I need to know. It takes 1 millisecond for a message to arrive to us at the station, whenever that is sent. Does that make sense? So if I send at 0, go back here. I send at 0, that arrives at 1. Yeah, as even. Send at 1 arrives. Both sides. Send at 1, arrive at 2. It requires 1 millisecond to arrive. Okay. Make sure this is a full duplex. So what information are required? You know yes, you need to put it. Don't put R, it's an iMessage.
Oh, right.
It's an actual iMessage. An R is required whenever you are going to time.
Yeah. I wrote an I as well.
Yeah, because you're doing that. R is one. I is information. First time, 0. Acknowledging receiving 1.
Acknowledge the lead is 1. Because it acknowledges it's got this, then it shares this right above it.
No, it should be 0, so it should be 2.
Acknowledging receiving 1. So it's not just acknowledging receiving.
Oh, yeah. It should be just
5 and acknowledge it.
And then follow it as it is.
6 and 7
Yes.
don't contain
So first of all, I and 0. This is S. Is I, S equals 0. So we need to I for it. So I for it, S equals 0. I would say the things that makes sense more. So what's the rule with more? So you continue. Same thing. Put an arrow so you know where the message is going. Where is it going? That'll make life easier. Because in here, you sending and receiving doesn't make any sense.
completely messy. I thought I was doing that the right way.
This one will copy that one is no problem. This one's set up because I need to have it going. Put the details, you don't want to lose track.
Let's run this account.
I'll give you another 5 minutes and I'll do it.
What else do we do once we write it out?
Sorry?
What else do we do once we write it out?
What else do you do?
If they acknowledge it, one draw. Like
You haven't drawn everything. You draw it, put all the details, the variable changing, the variable changing, this information. You'll be marked, not based on that. You'll be marked based on the information within that. So don't draw them this way. Draw them in that way. Put it in here.
And then obviously there's a 4-second millisecond.
So you can give me information within. So are you be marked on the message? You be marked on the variables
and then pre-sending
do it in this way.
a,
I'll put the time just so as it is. Put it in this way.
when it's
Should you receive a window size is
Be
3.
careful, you made a big mistake. 0 sending, arriving at 0, no, doesn't
1.
make sense.
No.
So you should arrive at 1,
yeah.
because that will lose everything.
Oh,
If
yeah,
you don't
yeah.
make it right, you will lose a lot of things. Do it again,
Yeah.
put them in this scope.
Yeah. And it
Yes.
says window size is 3, so after that, that's 1, 2, and 3. It should receive an acknowledgement.
No. The window size is only indicating how many messages you are allowed to send
Oh, yeah, yeah,
before it times out. The timer is the one will indicate when do I receive that acknowledgement.
Oh, I see.
Whether I require it or not, that's a different question.
Windows status.
The last one you sent was received. So neither, well, they know that there's nothing to do. Nothing sent.
The trick is to practice it like so many times, because as much as I try to help you with it, unless you practice it, you cannot understand what I'm saying.
So, with the Windows size being 3,
Okay.
you send 3 packets down and receive no.
That's a mistake. When you do it this way, especially using those colors, you cannot rectify it at all. If you are going to scratch things, no one will understand what's happening. My other advice is to follow the time.
I went down.
Yeah. So you say 0, 1, and there's a 1 coming back. And the other one, you missed already 1. 3 and 4.
I see.
Is that right? So that should as well rectify it. So again, doing it that way is better. You always update your variables whenever you send messages, because if you don't do that, you'll lose track.
Yeah, just like that.
So what was the question again?
Just because
The window size here indicates you can send 3, the 4th you cannot send.
yeah, that's
You
what
need
I'm
to
saying.
wait. You need to receive an acknowledgement before you send that. When and why, I'll hopefully show it to you.
Yeah, well, I was saying so 4 down to 1, 2, still 5.
Yeah, but how do you rectify that? You don't allow it to send.
So, yeah, that's what I'm saying.
So you
Oh, right,
delay,
right.
yeah,
Okay,
again, that's what I'm saying. If you don't allow it to send, you delay it, and you should send an acknowledgement before it times out. That's not part of the question, but you need to know when to send it. As I said, you are running a perfect question that shouldn't time out, shouldn't have more than window size.
Okay,
So you should
just
you should follow the rules.
Yeah, I was
Even
trying
if
to
it
draw
doesn't
the
say
diagram out.
Oh yes, that's the problem. 2 minutes and I'll stop. Yes.
Yeah, sorry, yeah.
Okay. First, there's an example message within those. You need to put an acknowledgement within the message. So we have an I, you have an I, and you have an S. S equals and then an A. So you follow the message. Put an arrow here. So you know where it's coming from where to where you track it. So this one is sent out. But it's sort of saying about first of all, will it time on or not? Is the window size fine or not? And what about the time? Will it time out? So that's one.
It's after every 3 minutes is one set.
Because this should have.
It freaks out and says, oh, maybe it's not received.
Alright, that's why you need a acknowledgement to still do that. So in other words, this is doing your
Windows size. How many you can send.
does any at the moment, but in some cases you'll need that.
So just carry on.
Just carry on. At the moment there's no issues, but eventually you'll have that. Okay, let's answer the questions. This is roughly fine. 6, 7, 8. How many is this window size? Yeah, so time, the window size. Window size is the number of messages you are allowed to send before it's been acknowledged. So the 8th one should be true. When you shouldn't time out. You are running a panic question. So shouldn't time out and shouldn't have the actual modeling response. So in reality, what I'm saying is you need to receive an acknowledgement from the 4 times out. Known actually. I'll explain that. Yes. When do you need to send the message?
Before 10 as well.
Yeah, it's a full duplicate. Yeah, that's right. Yeah, acknowledging two. Just update the details because the receiver, you should have updated eventually because 0 to 0, yes, that's the one. Then you have 2. This should be 2. So you are because if you don't receive those, that's what you're doing. Okay? Now let me solve with it because the time won't be upon us. Where the pens?
You left here.
Okay. No, there's two there. I need to use those two. Okay, so let's start. First of all, we all start with zeros. With that in mind. Start with the time. Don't rush it. Don't draw everything and then find out what's happening because that will make life miserable. You don't want to, in the exam, start deleting stuff and then writing it again. You will just panic. Don't do that. Do them step by step. Make sure what's your window size. Make sure what's your timer. Put them aside and understand it. You need to know that a message will require 1 millisecond to arrive. So in some cases, some of the students was saying that a message sent at 0, arriving at 0. That's not the case. Send 0, arriving at the 1 millisecond. So you need to put that in here as well to track everything is running perfectly. So assume when I've sent, it arrived in 1 millisecond. What things I need to track as well is this is a full duplex. So you have an iframe with a sequence number and an acknowledgement together with the message. So let's start. Let's follow the time. Tell me, what's the first message sent from where to where?
A to B.
A to B at 0 millisecond. So this is an iframe because I'm indicating it's an information frame. S equals 0, starts with 0. A, you haven't received anything, so you're not acknowledging anything at the moment. You just say 0. Nothing have arrived to acknowledge. Sender, sequence number 0, acknowledging 0. Nothing is there. First thing, you need to update your variables. Don't leave them to the end as well, because you lose track. So is the variable of the sender at the moment equal to the variable of the receiver? They are. 0 equals 0. I increment my variable of the receiver. Note that I'm incrementing it when I'm receiving it. So I'm incrementing it at the 1 millisecond, not at the 0. But I'm incrementing my sending at the 1 millisecond because it's sent at 0 millisecond. So track that. Don't delay the increment or rush the increment. I'm sending at 0 and increment at 0. I've received at 1 and increment at 1. I'm acknowledging receiving nothing. 0 at the 1 millisecond. Is that clear? First step. Everyone. Okay. What's the next message? 1 to 2. No, first 1. Where to where and in what? A to B at 1 millisecond. That's what you want to know. So 1 arriving at the second. You might not find them aligned, just align them in your papers because it's easy, it's hard for me to look at them and align them perfectly. So this should arrive at the 2nd millisecond, okay? With this second, so you know. Is that clear? What's the information? Tell me.
S equal to 1.
Still acknowledging 0. Nothing can be received from that side. So you're not acknowledging anything. Is the variable of the sender equal to the variable of the receiver?
Yes.
You increment this by 1. Still acknowledging 0. And you increment your sender by 1. Until now, straightforward. Nothing is happening. When is the other message? Where to where?
B to A.
B to A at
3.
frame 3. So this is your frame 3. Sent, arriving at frame 4. So first of all, we had a timer, did we?
Yeah.
So your timer is 1, 2, 3, 4. So in other words, this saved us. Why? Because tell me the information here. You have an iframe. S equals 0. This is the first message from B to A. It's not 2. That's why I'm using 2 colors to keep it track. I'm sending those, so these are not the same information. So this should be 0. Acknowledging what? 2. Why? There are 2 packs arriving, so you are acknowledging this 2 inside your acknowledgement. Why? Because those arrived, 1 and 2, which is this one. You've acknowledged receiving those two. Is that right? Is that clear to every one of you? Let's update the information. Is the variable of the sender, look at this one, equal the variable of the receiver?
Yep.
Yes. I increment my variable of receiver to 1. I'm acknowledging receiving what? Two messages. And I increment my sender to 1.
We need to track that.
It's easy to make a mistake, very easy to make a mistake. So in other words, it did not time out. 1, 2, 3, 4. This message has a piggyback of an actual acknowledgement of those 2 frames. If this was not in the question, I should have an RR, acknowledging receiving. That's the trick. Yes. It's 0, yes?
Why?
Did not receive anything. He did not acknowledge those 2. This guy is acknowledging to this guy, I've received you 2 messages.
Right.
So is a person telling the other one. So if I send you 2 messages, when you send the acknowledgement, I update my information,
Of the number.
not you.
Yes.
You update your information whenever your messages are acknowledged by me.
Oh,
It don't make sense. Okay, so let's continue with the time. What do you have next? Where to where?
B to A again.
B to A
At
at the
4
4
millisecond.
millisecond, arriving at the 5th millisecond. Give me the information. S equals
1,
A equals
2.
what? Still 2. Nothing changed. You're still acknowledging those 2. Nothing have changed. Nothing have changed. This is 1. Variable of the receiver equal variable of the sender equal to variable of the receiver.
Yep.
Yep. I increment my variable of the receiver to 2. I'm still acknowledging receiving those 2. I increment my variable of the sender to 2. Let's continue the message. Where to whom and what time? A to B at 5. So 5 arriving at the 6. Give me the information. I. S equals
2.
2. So look at that. 2. This is a continuous of those 2. A equals, now you need to know that. 2. That's it. Why? You've received those 2, you're updating your information. I've received those 2, I'm updating it. So this will be 2. Let's continue with our variables. Is the variable of the sender, which is this side, equal the variable of the receiver of this side?
Yes.
Increment my variable of the receiver to 3. I'm acknowledging now, returning to you, I'm acknowledging to this side. I've received those 2. And I'll increment my sending to 3. Yes, it is a bit tricky, yes, it's a bit confusing, you need to practice it. But you need to understand the concepts now. And when you go back and practice it, you manage to do it. Let's continue with the messages. What's now? What?
Now,
Where and why? Be careful. Consider the window size as a buffer. Let's consider it as a buffer. You're allowed to send only 3 messages. Is that right? Unless they are being acknowledged. So S0 set, first one. S2 until S1 set, the second one. I'm speaking about A because each one of them has its own window size. Still it's not full. 1. Second, I've received an acknowledgement. So in reality, that resets back to 0. So whenever I receive an acknowledgement, your window size will go back to 0. Is that clear? You know that? So that's how a window size works. Let's continue with the question, and then I'll make everything hopefully clear. Don't worry. Let's say that 5 sent to 6. What do you have next? From where? 6 to 7, A to B. Tell me the information. I. S equals
3.
A equals
2.
still 2. Nothing happened. No messages have arrived to acknowledge. Let's update all information. Is the variable of the sender equal the variable of the receiver? You go to 0. Don't go to 4. Don't forget that. We go back. We revolve upon 0, 1, 2, 3. 0, 1, 2, 3. This is 0. Acknowledging 2 still. And I update my virtual descender to 0. Let's continue the messages. There's the one going from 7 to 8. One is going from 7, from A to B. First of all, can I send that? And why?
Yes.
Why? Still, so still I've only sent 2. And that allows me a space of 1 as well. So everything is fine. It's not timed out. I have 4 milliseconds, so that's fine. Just whenever you send a message, virtually put that there is a timer of 4 milliseconds for each message before it's being acknowledged. Put that in mind. So until now, everything is perfect. I'm not worried. S equals 0. Goes back. Still acknowledging, receiving the same 2 I've received. Is 0 equal to 0?
Yes.
I increment this to 1. This is still 2. I increment my sender to 1. Continue the messages. Where, to whom, and when. 8 to 9, from A to B. Can I send that?
Yeah.
No.
You can, but it'll
So
get
you cannot
rejected.
send that message. If I send that, there will be window size more than the 3. It will be 4. So I cannot send that. So in other words, this should not be sent. You delete that. You wait. So the question is, I cannot send that because my window size is full. When can I send? I have a message at 8, a message at 9, a message at 10. What do? I delay until
4 seconds.
not 12. Until
Time out.
12.
yeah, okay, just one of you. That's what's happened now. This is multiple access protocol. So one of you raise your hand to tell me a question. I need what? So yes, what?
You have to wait. It's
Until?
going to time out.
When is that?
At 8.
9. So
9.
before it reaches 9, what do you need to receive?
Acknowledgement.
You need to receive acknowledgement. So you send an acknowledgement, regardless of the question. You send an acknowledgement from 8, arriving at the 9 millisecond. And that should have an RR or an acknowledgement. Either one is fine. What do you put here, a number? You tell me. Just look at the receiver. What's that? Is it 1? Oh, sorry, I haven't seen this. Sorry. Yes, you just copy 1. Whoever said 1 is fine. You just copy 1. I've received 1 and everything before that. Is that right? These should be in the exact. Sorry, these should be exactly the same. So this is 1, and there you put your acknowledgement at the 1, wherever that's the 9 milliseconds. What happened? Just let me finish that small bit. What happened to the 8? That's been delayed. What happened to the 9? That will be done as well because 8 is pushed to 9 and 9 is pushed to 10. Okay? Saying to you, I'll continue your question.
How does it know to send the acknowledgement? Does it just automatically?
No, the acknowledgement should be sent exactly before time's out. The question says, people, why not before that? Because the machine, machines when they operate, they leave it to the last millisecond. And you know why? Because assume in your head there is an actual message sent before that. Therefore, you waste an acknowledgement because there might be a message before that's been sent, i.e. an iframe. But there isn't, so leave it to the last millisecond.
For the full marks of the question, do you have to note down the delayed?
It's very, if you manage to do everything and you just not put delayed, I will not penalize you, but
Okay.
it's
Good-
really easy. Just
good
put
to
D.
know, yeah.
Just, I don't know it will be delayed. If you didn't mention it, I'm fine with that.
Yeah.
But it's not a big deal. My main concern is actually your state and the actual information within those. At the moment, is this clear?
Yeah.
In most of it, but I mean concept-wise. If you understand the concept, everything should be fine.
So if there's 4 numbers in the packet,
Yeah.
it has to wait for an acknowledgement before it's sent.
If the window size is
It's
F4, then it needs, it
full.
sends
No,
full.
full.
Full, yeah. And by full, if it's a 3, you're allowed to send 3 only until you receive an acknowledgement. When do you receive the acknowledgement? That's bounded by the time. Before time's out.
Will you receive one before it times out?
Yeah, exactly before time's out. Because time's out 9, you should receive it at 9. Whenever you time out, you should receive it on that one. Because if it passed 9, the mistake of the question. Again, this question is written, should be in a perfect, in an ideal, in a comprehensive way. There should not be any mistakes. Until I tell you there's a mistake. So let's assume now I've said in the question, error occurred in the 7th millisecond. What does that mean? This did not write. I'm not going to do it now, but that's what it means. Therefore, you need to work on the rejection and the not acknowledgement. I'll leave that to the exam question. I'll leave that in the lecture when I'm doing exam. It will happen in the exam question. Don't worry about that, definitely. But when will that happen? How will you deal with it? That's the case. It's 25 marks. I'll try to make it as complicated as I can. Not as complicated, you cannot solve it, but in a way you can manage to do it. Next lecture, I'll bring the last year exam question, and you see it's straightforward in a sense. You want to ask a question here?
if you send 3 messages
Yeah.
down the line, which is IS equal to,
Yeah.
the window size is limited to 3, isn't it?
Yeah. 1, 2.
So the next message should be IS equals 0, won't it?
I do not understand the question. Sequence number doesn't relate at all to window size all the time. You follow the sequence as it is. You put a sequence number here on the side, and you say there are 1, 2, 3, 0, 1, 2, 3. That's it. They revolve over time.
Okay.
Doesn't mean they reset. They don't reset. They continue as they are. I haven't changed it. If I've changed it, I made a mistake. You have 15 minutes, so I'm happy to continue the question.
Yes.
Yeah.
Let's continue with it. So 8 is delayed. 1 is delayed until 9. So that's sent at the 9th millisecond to arriving at the 10. And 9 is delayed to be sent at the 11. 10 is delayed to be sent at the 11. So 8 is delayed to 9, 9 is delayed to 10, 10 is delayed to 11. Okay? Let's put the information here. I frame S equals 1. I'm acknowledging what? 1. Sorry, what are you acknowledging?
2.
You tell me. And why?
2.
2.
2.
2.
Because you only received those 2.
Yeah, they're
This is an RR
not
frame, doesn't have an actual information in it. I haven't updated my receiver. I just updated my acknowledgement. So yes, you received 2. Thank you. You're acknowledging 2 only. So is 1 equal to 1? Yes. I increment this to 2. I'm acknowledging still receiving 2, and I update my sender to 2. I frame S equals 2. Still receiving 2. Is it equal? Yes. That goes to 3. Still receiving 2. Still acknowledging 2, sorry. And you update your sender to 3. I frame S equals 3. Still acknowledging receiving 2. Is 3 equal to 3? Yes. That goes to 0. This is still 2. Your receivable will be 0. What is the other message? So first of all, this is now full. 1, 2, 3.
Yeah.
It times out at 1, 2, 3, exactly at the 13 millisecond. If I did not receive a message in the 13 millisecond, it will time out. So I need to receive an acknowledgement. Well, let's see. Is there a message going back?
Yes, yes. there
When
is.
to where?
13.
So send that.
But
Is it 12 or 13?
12.
Should
Oh,
be
it's 12.
12.
It is 12.
Yeah.
12.
So it's 12 arriving at the 13. So it did not time out. Tell me the information here. I frame S equals 2. Perfect. A equals
0.
0. Sorry, exactly. You just copy your receiver. 0. Is the
Yeah, took
variable of the sender, in this case, is this one, 2, equal to the variable of the receiver, which is 2. You see how it is now
Yeah.
here? If it's yes, it is. You increment your variable of the receiver now to 3. I increment my variable of the sender to 3. I update my acknowledgement in the side to 0. Any questions? See, it's just tracking it, following the time, making sure
Does it
everything's
sound really silly, but S is the same as the S up there, right?
Yes, yes. No, again, that's a variable of sender. This is a sequence number. It's not the same. This is called sequence number. That's called variable of the sender. Did you understand your window size and did you understand your time? Let's for the last group, I've shown them an example by one of the students. I said, I'm stopping here. I'm not continuing with this question. Look at this one. Let's assume this is a sender and that's your receiver. Let's say your window size is 3. Let's make it 4. Let's change. 4. Your timer is 10 milliseconds. And I'm telling you that there is a message sent at 0, 1, 2, 3, 4, and 5. Okay? That's your 10 milliseconds. So that's the first message sent, second, third, fourth. Let's say just 4 messages. How many do I have? Let's say we have 4, and I said there's a 5th one. Am I allowed to send that?
No.
I'm not allowed because I only have 1, 2, 3, 4 already sent, and I only have allowance of 4 messages. When can I send that? So I've delayed number 4. Is that right? Because I cannot send it. I should delay it. So is that delayed? Until when? My timer is 10 milliseconds. So what do I need to receive?
Acknowledgement.
When to where?
From
9 to 10.
Exactly, 9 to 10. This is how it works. My timer is 10. I've received an acknowledgement, indicated I've received whatever number is here in the acknowledgement. Therefore, you are allowed now, at the 10 millisecond, at that 10 millisecond, to send that one is being delayed. So, did you see the correlation between the window size and the timer? This is how it is. Hope that makes things a little bit better.
What was the last arrow for? No, here on
Which, where are we? Here?
Yeah.
Oh, this should be the one that's been delayed. So this should be the blue. So that's an iframe. I haven't put details. I just put I, and I said there's a fourth one.
Okay.
That's delayed until this one. Why? Because your window size is 4. And why it's delayed to 10? Because the timer is 10. You shouldn't receive an acknowledgement and then you send that. So I haven't put any details. I'm just trying to make a case of the timer and the window size. Is that clear? Exactly. Yes.
So if the window size was 6 or something, then
Let's say it's 6, and
go
let's say you have 7 messages.
yeah.
4, 5, 6, 7. You cannot send.
Yeah, so
You delay it until that acknowledgement goes back.
Why would if? Oh no, never mind. I'm sorry. I thought about it.
Good. Save me explanation. What I'm going to do in the exam.
Lecture.
Yeah, in the lecture. Thank you. In the lecture, I'm going to. First of all, I have 2 questions from last tutorial. I'll try to do that. One of them is the structure of point-to-point with the services, and the byte something was that. So it's very simple, explaining some details. And then I'll give you an exam question of last year. I'll give you the exam question. I'll ask you to practice the inside in the lecture. So we'll take you like 10 minutes, and I'll do that afterwards until I show you the main details of how do we do that. And then we solve the lecture. Okay, so that'll maybe take an hour of the lecture, and we'll solve the other half of the lecture. But it's very important for the next lecture you will have a feeling of how exam questions come, because they are very similar each year.
I was just gonna say, if the window size is agreed at 7 or whatever you put there,
Yeah.
once it's received 7 packets, why would the second machine not just send an acknowledgement?
It doesn't send the acknowledgement until before time's up, because you might have an iframe message going at the 8. You cannot anticipate, because maybe there is an 8 message going from B to A, which covers the actual acknowledgement. So if that's the case, then your RR you are going to send is going to be redundant. So you just create an overhead. If you want to ask me more questions, more than happy. If you want to leave, I'll finish on that. Your call. I'll be waiting for you guys. For those who want to leave, by all means. For those who want to sign, please come in and sign. But I'm happy to answer any questions you want. Okay? So I'm saying like 5-10 minutes afterwards. Thank you.
Get some